The first process that we look at that takes place in the eye is called accommodation. And that is when the lens changes thickness to refract light for near or distant objects. So the lens will become thicker or thinner depending on the distance that the object you're looking at is from your eye. So we look at objects being near objects, which is generally closer than 6 meters, but obviously it's not a cutoff. Your lens, it doesn't go from being completely rounded to completely flat. It's just the two extremes. So closer than 6 meters is generally a near object, which means your lens is what we call more convex, so it is a rounder shape. Whereas a distant object is further away than 6 meters from you. Again, it's not an exact cutoff point. It's more a spectrum of lens thickness. And that distant object will then make your lens much less convex, so it becomes flatter rather than rounder. So the important thing to understand here is what structures change the shape of the lens, and therefore how does that change the shape of the lens. So let's have a look at some background, which is not examinable. It's just for your understanding. So to remind you, what we're looking at here is these structures associated in the ciliary body, which is part of the choroid. So this is the ciliary muscle, that little circle, and that's the ciliary muscle. Now, what's important for you to understand is that that ciliary muscle isn't like a standalone thing there, that's a circle. It's actually a cross-section through the eye. So if we looked at the eye from the front, so if you look at it from the front, behind the iris, what you actually see is the ciliary muscle is a complete circle. Don't get this confused with the structure of the iris though, but the muscles work in a similar way. So the ciliary muscle wraps around the lens. There's the lens in the middle. So that's the lens in two different pictures. And what happens is when you see looking at a near object, that ciliary muscle is actually a sphincter muscle. So what that means, if you think of your sphincters, you've got an anal sphincter. So let's choose the most obvious example. The anal sphincter, it works where it contracts and closes your anus, okay? So it contracts and you can squeeze and hold in if you need the toilet. Same thing similar with your bladder. So when it contracts inwards. So when your ciliary muscle contracts, if you compare the thickness here, it's contracted, but it contracts inwards and closes the circle around the lens. So here's the lens. Now, very importantly, attached to the lens all the way around and attached to the ciliary body are these suspensory ligaments. So if you think about it, I'm using an elastic band. My hand at the bottom here is the convex lens. I'm only showing it on one side. If the ciliary muscle goes from being a little bit more relaxed to contracting and moving inwards, look at those suspensory ligaments. So what I'm trying to show you is the difference between a slack ligament. You can see it's slack. It's got lots of, doesn't have tension on it, versus this right-hand picture over here. If the ciliary muscle will relax, it pulls the suspensory ligaments, which is anchored onto the lens on this side, it pulls them and they are now tightened or they are taut. So when the ciliary muscle, the sphincter, relaxes, it opens upwards. So it opens upwards and pulls on these suspensory ligaments. Now that would be attached to the lens, which then pulls the lens, and the lens can therefore flatten. Whereas if those suspensory ligaments aren't being pulled tight by the relaxed muscle, and the muscle contracts and moves inwards, the lens can then bulge again because it's not being pulled tight upwards like this. So when the suspensory ligaments, if we look at this picture here, when the ciliary muscle contracts, it moves inwards, which makes the suspensory ligaments slacken, which then allows them to not pull on the lens. The lens can be bulgy. If the ciliary muscle relaxes, so it opens the sphincter, it pulls tight on all of these suspensory ligaments, which pulls the lens into a much flatter position. So I'll show you that from the side, but again, you don't need to know this exact structure of the ciliary muscle, but it does help you understand the fact that it's a sphincter. So when it contracts, the muscle moves inwards, which is a little bit of a funny thing for you to understand. Now, I'm going to do something a little bit odd here. I know that this is on the left, and ideally you want me to start on the left-hand side, but I always learn accommodation of a near object. So I'm going to start with a right-hand side diagram, and I'll tell you why. If you take a piece of paper that's nearby and you hold it close to your face and try and read the words on that piece of paper, you will feel, if you hold it like right in front of your face, you will feel your muscles in your eyes start to tire. You can physically feel them working. So that then helps me to think, well, this is a near object. I'm holding the piece of paper close to my face. So therefore, I can feel the muscles contracting. Therefore, I know that these are the ciliary muscles in the ciliary body that are contracting. So it helps me set up my step 1 of my process. And if in an exam they ask you for a distant object, you can still use the same theory, but then you just know instead of contracting, the ciliary muscles relax because you don't feel as tired. Then, remember, when those ciliary muscles contract, these little muscles, they contract inwards. You can see they look a bit thicker here. The muscles look thicker than in the other picture. So they've moved inwards, which means they're not pulling on the suspensory ligaments. So the suspensory ligaments slacken, which means they become loose. So it's the opposite of tight. So they slacken. Please, grade 12, we do not ever say the suspensory ligaments relax. They are not a muscle. The muscle will contract, and the suspensory ligaments, you want to say relax because, okay, cool, it's opposite. No, they slacken or they become slack, which means they're not pulling on the lens from all sides anymore, like I showed you in that previous picture. So the tension on the lens decreases. So then the lens isn't being pulled. It's like taking off skinny jeans after a very long day of wearing them. The tension on your tummy will decrease and you can let your tummy go. So that means the lens becomes more convex, which means rounder. So if you look at this picture, it is physically a rounder lens than that one. And the reason it becomes rounder or more convex is to refract the light rays more. From a close object, you're looking at the object right in front of your face. Those light rays are coming in from quite steep angles. So if you think of looking at someone standing a meter in front of you, you've got light rays coming from their feet and light rays coming from their head, or coming in at completely opposite directions. So they need to be bent a lot to make sure that they focus onto your fovea at the back. Whereas if you're looking at an object that's far away, if someone is standing far away from you, by the time the light rays from their head reach your eye and the light rays from their feet reach your eye, they're not as steep. They're coming in at a much lesser angle. So if I just draw it in coming in here, from a close object, the light rays can look quite steep flying in there. But from a far away object, they kind of straighten out. And if you look at when they enter your eye, they're a lot less steep than if you're looking at a close object. So your lens needs to do a lot more work to refract, to bend. Refract means bend. You need to pay attention to that word there. To refract the light rays more. So then the light rays will be focused onto the retina. So moving on to a distant object, it's the exact opposite. So you can learn a near object really, really well, knowing that you start off with your ciliary muscles contracting, suspensory ligaments slacken, etc. Then everything is the opposite. For a distant object, the ciliary muscles in the ciliary body will relax. Suspensory ligaments will tighten, or we say become taut, T-A-U-T, taut. The tension on the lens will increase because the lens is being pulled from all sides. So the lens will become less convex, which means it becomes flatter. So light rays will be refracted less because that doesn't need to be refracted so much. The light rays are coming in at a further away angle. And that means the light rays are then focused onto the retina. So that point number 6 at the end is always a mark. So at least say that if you don't know what else is going on. But you study the step-by-step process. And as you can see, we've got the ciliary muscles contract for near objects, relax for far objects. Suspensory ligaments slacken or become taut. They tighten. Tension on the lens will decrease or increase. Lens becomes more convex or less convex. Light rays are refracted more, light rays are refracted less. So it's a case of opposite adjectives. Last thing to say on this is that you must be able to relate a picture to the distance of the object from the eye. So seeing the rounded lens, you need to know, if I asked you, describe what happened to lead to the lens to look like that, you need to know that the person was looking at a near object. So you've got to study this process with the picture in mind.